Hello everyone, today is February 6, 2022 and this new quiz is the intersection of two arrays. Before I start, I recall I have implemented that problem and finished this problem a few maybe weeks ago, and at that time I implement that by the hash table. So that's simple to hash one numbers first array and then check with the number 2. So usually I hash the longer one and check the short one. Yeah, that's faster. And back to the today this problem represent on the in the binary search section, the chapter. So I think we better to do that with the binary search. And I'm thinking, let me finish the problem. So given two integer arrays, number 1 and number 2, return an array of their intersection. Each element in the result must be unique, and you may return the result in any order. Example, so array 1, 1, 2, 2, 2, 1. Array 2, 2, 2, so output 2. Input another example, and array 1, 2, 4, 9, 5, and 9, 4, 9, 8, 4. So duplicate will be the 9, 4. So 4, 9 is also accepted. So constraints, the length is 1 to 1000, and the numbers is 0 to 1000. So numbers has 0, length at least 1. Okay, so again, basically based on the binary search strategy, so I think we need to sort one array. Let me recite. That was already a previous analysis I made. Okay, so first one I do need sort array, then check binary search another one. I'm thinking for search another one, how I handle the duplicates. Do we need sort the second one to handle the duplicates? That's a few different way to handle the duplicates when you search in the second array. On top of my mind, I'm thinking to sort the second array also and just search one by one. Yeah, that's the one. Another one is we don't do sort. We just do what? No, I don't have second way to do that. Easier than this one. I'm thinking maybe I could do handle. I don't sort it. We just compare each element from the array 2, but excuse me. But when I generate the output array, I have to sort it and handle the duplicates. That's harder. So we don't need that way. So okay, basically I do need sort two arrays, first one and second one, and I searching the first one from second one elements. I need compare which one. Let me think. I'm thinking maybe a little optimization. So to first one, I maybe need sort both and compare the length of two arrays and searching the shorter one. That will be faster. Okay. Okay, that's the case. Let me do the implementation. Again, I'm going to copy the one. Intersection of two arrays. Intersection of two arrays. Let's see. Okay. Okay, so since we do need, I prefer to call the quick sort in this function. So quick sort has a compile fundamental function needed. So I just do implement that and compile constant void pointer a and constant void pointer b, and just return pointer convert to the integer pointer a minus pointer control b. Okay, so that's the one. So declaration. So I'm thinking if I need. Okay, I could do this. I need to declare two pointer base and the searching base. Let me do searching base one and check one. Searching base. I'm thinking how to name the second pointer for that one. I'm searching base. Second one will be the elements to get based on the target. Okay, the target site. Okay. Okay, so I declared two pointers to do, because later on I will compare two arrays lengths, and I will set the searching base as the longer. I'm thinking which one is better. So okay, let me do a think. Okay, so let me think. So if m greater than n, maybe it's more than n a lot, and we just first one we just do n times log m. Okay, so that's log m means we sort plus log n. Okay, that's the one. So we set searching base as the longer array, and we searching each element from shorter one. Okay, and that's one. Second one will be we sorted both, so that's same log n, but but we searching element from the longer array. So that's two different time complexity. And let me think. So that really depends on what's the big difference between them. So that will be for the first one, that will be basically a n log m. And this one is really hard to say because we don't know how big that is, but based on the length will be the 1000. Let me search. So the log 1000 base 2000 will be log 1000 base 2 is 9. Okay, is 9. So that means 9 equals 9.9, whatever. It's about 10. So, and log 1 is 0. That means 0 to 10 is not big differences. So, let me see. So, for example, I'll take the calculation for that one. Okay, log, for example, m is 1000. It's about 9.9 plus m is 1000 log maybe 0. Okay, that's okay. Let me think. 10 maybe 10. 2. Okay, less than 2. And calculate m equals 1000 and n equals 2. Since there's the length equals 1, that's 0, but anyway, I will like do this calculate. Okay, 2010. Let me think simple life. That's equal to. Okay, let me do this one. So that's maybe 3 and 9.9 plus 2. Okay, that's only 32. Okay. Okay, based on this case, so for the side case, that's if the m is much greater than the n, so the better to searching base that longer one and searching less as we can. Yeah, that's the case. Yeah, that's the case. So that means that's worse. We set the search base and target base, and we compare the length of the two arrays. That's worse that. So okay, back to the implementation. So let me see. Okay, if number one set equals greater than number 2 size, we just Okay, so the search base equals numbers one size, no, numbers one. Okay, the target site equals numbers two. Else that will be swap. Okay, I do quick sort the numbers one and the numbers one size and size of integer and compile. Okay, we just replace 2 and 2. Yes. Okay, we also need index to search. In int index and int the target. For I equals 0 and I less than okay, the length, we also need a length here. Let me check. Length always equals the shorter one. Okay, shorter one, no. Plus okay, so I remember I need a declared return also as well. Let me see, so integer I'm thinking how I could malloc the return value about that. Initialization return equals for simple, I just return malloc the shorter length of the two array. Yeah, calloc add length size of integer. Or target equals if target equals numbers, no numbers, the target site 0, no 0i, we just continue. Else, okay, and else we do binary search. Okay, then we need bool binary search int the numbers, int the numbers length, and int the target. Int star and made stars equals 0 and equals number slice -1 and made equal okay, while start less than end, we start a loop. I add equals condition also here, so while if made equals start plus and minus start divided by 2, if numbers, we don't need numbers 1 here, so we just need the numbers. Okay, numbers array, okay, made greater than the target, then when you're searching left side, so the end will be made -1. Else, if numbers made less than target, we just start equals made +1. Else, return 2. While return false. Okay. We also need an index here for the if binary search search target we also need the second star length here, so the length target array length and also search length. Okay. Search. We just swap the length here, and here will be the search length, and here will be, no, that will be the target length. Target will be the target. If that will be true, we just need to return index plus equals target. Return size Yeah, that's the search. Okay, return. Okay, basically I'm thinking I need sorting the two input arrays, and I also compare the two array size and the size set the longer array as the searching base. Yes, I searching the shorter arrays atom, each atom from shorter arrays uh, from the longer array. That's why I set different lengths here, and I set the sorting here. I just go to the search target side, the array, and do the binary search for each one to return. If that happens, we just add to the return, and else just return it as is. And we have the index equals 0 as the initialization value. Okay, I think that's all for this implementation. I'm going to run it on the Leetcode, and going to run the first example. Okay, I need to initialize this int to a none from the void inc. Okay, void pointer. Doesn't matter. Okay, so 557, 57. Okay, going to searching the target array length. Okay, run the example code. Run the example code. $63 target site. Okay, so subscribe special value is neither array nor pointer or vector. Okay, target search. Okay. Okay, run that again. Okay, I got none. Now, I hate the issue, so I'm going to print someone here. Okay, we're searching. Oh, how that happen? Okay, that's return false. Okay, I didn't play. I got the target is -1 on how that happened. Let me see the target. Oh, okay, that's wrong one. So else target equals target site. Okay, I got right answer. Let me try to submit. Okay, that's accepted. So I think the basic logic is right. So let me comment out all the debug. And submit. Okay, let me check the. Okay, it's. Let me do that again to see if the performance keep constant. So that's accepted again, and this time is bit 65. This time 47. Okay. Summarize. So basically, the logic is do the quick sort the two input array, and we searching the shorter. I get each element from the shorter array and searching that from the longer array. So with the binary search. So the time complexity will be. Okay. So let me write down something. So the time complexity will be first one, the numbers greater than, okay, numbers, if numbers greater than number 2, then time is big O log numbers 2 log numbers 1 size. And what I do modified, let me think. I didn't change anything for the binary search. I just, the top of my mind, the last modification is I do else. So we don't do anything once the target is duplicate. Once that's not duplicate, it's a new number. We just make sure the target equals the target site, the current element. And I made some simple syntax fix. That's minor issue. So that was in the implementation. I do some variables after once we need it. Okay, I think that's all for today. Thank you for the watching. See you.